Let's look at find peak element. A peak element is an element that is greater than its neighbors. Given an input array nums, where nums of I is not equal to nums of I plus 1, find a peak element and return its index. The array may contain multiple peaks. In that case, return the index to any one of the peaks is fine. You may imagine that nums of minus 1 is equal to nums of n is equal to minus infinity. From this statement, we can infer that for an array size of either 0 or 1, the peak element's index would be 0 because the value at the lower bound of minus 1 and the upper bound of n is minus infinity, which would be less than the value present at the 0th index. So that would form a sanity condition. That is, if nums dot length is less than or equal to 1, then return 0. Now, in order to find a peak element index, we use a binary search technique. So we'd go ahead and initialize start and end and mid for our binary search. Start would be 0, end would be nums dot length minus 1, and mid would be 0 initially. We iterate while start is less than end. Each time we compute mid as mid is equal to start plus end minus start by 2. We do this in order to avoid the integer overflow condition. Now we check if nums of mid is greater than nums of mid plus 1. If this is a case, then nums of mid has a possibility of becoming a peak element. Therefore, we would then have to compare between the range of start up to mid. So we'd assign end to mid. Else, we know that nums of mid won't be equal to nums of mid plus 1 because of the given condition here that no two consecutive elements to the right are equal to each other. Therefore, we can infer that nums of mid would then be less than nums of mid plus 1. And therefore, there would be no peak up to nums of mid. And therefore, we'd have to change our start index to mid plus 1. This loop would terminate when start is equal to end, and the terminating index would be given by either start or end, and that would be our peak elements index. So we can go ahead and return start. Let's try to run this. Now passes for the given input test case. Let's go ahead and submit it. Now the time complexity for this given solution would be O of log n because we use binary search technique, and space complexity is O of 1 since we do not use any auxiliary space. Thank you.